Okay, so first of all, if you were absent, I want to go through this real quickly, okay? So we're talking about trapezoids and kites. What makes these unique is this. Okay, what makes these unique is this. These are not parallelograms.
Oh wait, do the back side. Love that.
Okay, they're not parallelograms, okay? So if you take a look at trapezoids, it's not a parallelogram, and kites, they're not parallelograms. So these are the two odd children. I mean, you got a family of parallelograms. You got the square, you got the rhombus, you've got the rectangle. Those are the children of the parallelogram. Well, these are just kind of like the cousins, right? They're quadrilaterals, but they're not parallelograms, okay? So we looked at what a trapezoid is, one set of parallel sides. An isosceles trapezoid has the parallel sides, but also equal sides, right? Characteristics, base angles are equal, diagonals are equal, right? Okay, and on the flip side, we talked about kites. Definitely not a parallelogram, but we have adjacent sides are equal. Two sets of adjacent sides are equal. Turns out that these two big opposite angles are equal. The big diagonal cuts these angles in half, right? And the diagonals are perpendicular, okay? We also learned about the trapezoid mid-segment. If it's a trapezoid, it's a mid-segment, cuts it in half, equal, midpoint, right? Equal, midpoint, right? We learned that this base plus this base divided by 2 will equal the mid-segment, okay? Easy. So now let's take a look at our book and figure some things out, okay? So first of all, let's take a look at number 1. Okay, example 1, show that the quadrilateral with vertices at 0, 3, 6, 0, negative 6, 0, and negative 3, 0 is a trapezoid. Okay, so I'm going to go ahead and try and graph this the best I can. See if I can get those in here. Okay, so I'm going to graph my points. I'm going to be at 0, 3, 0, 6, 1, 2, 3, 4, 5, 6. Negative 6, 0, 1, 2, 3, 4, 5, 6, and negative 3, 0. Okay, so negative 3, 0. I must have something wrong.
1, 2, 3, 4.
3, 0. 0, 6. Oh, this is the wrong spot. This is supposed to be 0, 6 is 1, 2, 3, 4, 5, 6. Aha, there's my trapezoid.
There's your trapezoid.
All right, there it is. Okay. How do you prove it? By its definition. Okay, its definition says we have to have one set of parallel sides. Okay, how do we prove it? By its definition. So we need one set of parallel sides. Sure looks like, to me, like this side is parallel to this side. You guys agree? They look parallel. How do we know if two lines are parallel? Because we look at their slopes, and if the slopes are equal, they're parallel, right? So let's look at the slope, okay? So the slope is up 1 over 1, up 1 over 1, up 1 over 1, up 1. So the slope of this one is 1 over 1. The slope of this one is up 1 over 1, up 1 over 1, up 1 over 1. So we've proven it. This line is parallel to that line. If I can prove equal slopes, the lines are parallel, therefore it's got to be a trapezoid because we've got one set of parallel sides. Capiche? Does that make sense? Yeah. Okay. Let's look at number 2. Number 2 is super easy. Okay. So these two angles are equal, aren't they?
Yes.
What's angle L? It's that easy. What is angle L? 23. Easy, squeezy, lemon peasy. Right? Okay, now, we also need the measure of angle K, right? So here's what we know. These two angles are supplementary. What does supplementary mean? 180 minus 23. And who has a calculator? Should be 157, I think.
I do.
I think it's 157. I'll bet it is. 160, take away 3 more, 157. Okay. Okay, number 4, easy squeezy, okay? How do I find CD? It's a mid-segment, right? Let's go. 36 plus 12 divided by 2. 36 plus 12 divided by 2. 48 divided by 2 is, Landon, it is 24. Thumbs up, easy squeezy, 11 peasy?
Yes.
Okay, all right. Let's look at number 5. Now, number 5 is a little bit different. And let me use the value of x. So, this side plus this side divided by 2 equals the middle.
Wait, what did you do?
So, x, so I just called it x for CD. So, x plus 0.6 divided by 2 equals 1.8. So, let's just do some algebra, okay? Let's go x plus 0.6 divided by 2 equals 1.8, okay? So it's like an algebra problem. Now, I can solve, right? What am I going to do? I'm going to multiply by 2. Yeah, you're way ahead of me, Annie, I like that. Multiply by 2, everybody agree? Times it by 2. So x plus 0.6 equals 3.6, right? Minus 0.6, minus 0.6, and I get x equals 3. Okay, does that make sense?
Yeah.
Seem easy? Okay, now let's do 6. A little bit more challenging. We're going to do 6 and 7. I'll be done, okay? Let's do 6. Slide it up. So if I look at 6, this base plus this base divided by 2 equals the middle. That's going to be some algebra. That doesn't scare me. I can do algebra. So I'm going to go, all right, 3x plus 3 plus x plus 11 divided by 2, right, equals 3x minus 2. Okay, I'll do it again. Base 1 plus base 2 divided by 2 equals the mid-seg, okay? That's just a matter of doing some algebra. I can do that. Okay, I get a 4x plus 14 divided by 2 equals 3x minus 2, okay? So I just got a 4x, you can see the 4x, plus 14 divided by 2. Now I may as well just divide by 2. You guys okay with that? Because they both do divide by 2. So how about if I just go 2x plus 7 equals 3x minus 2. I mean, I just divided by 2. Divided by 2, divided by 2, right? Minus 2x, minus 2x. I've got 7 equals 1x minus 2. Plus 2, x equals 9, right? Agree with that? So far, so good? Okay, 7. Okay, these two are equal. These two, like in a kite, these two diagonal pieces are equal. Don't they look equal? So we'll just go 9 equals 1/10 x minus 1. Okay. Slide over. Okay, so I just said 9 is equal to 1/10 x minus 1. Plus 1 plus 1, I get 10 equals 1/10 x. Multiply by 10. Multiply up by 10. X is 100, right? Okay, and that's all. Not bad, huh? Okay, so